There is an intuitive, universal rule of thermodynamics in space. Stand close to a star, and you get hot. Move away, and you cool down. Look at Mercury. It is a barren, scarred world that sets the baseline standard for this rule. Because it orbits virtually on top of the Sun, the planet absorbs an immense, punishing amount of direct solar radiation. This map illustrates the mechanics. Mercury sits 36 million miles from the heat source, resulting in mathematically logical extreme surface temperatures. But panning outward, we hit a snag. Venus orbits twice as far. By all logic, the temperature must drop. Yet the surface of Venus sits at roughly 900 degrees Fahrenheit. That is hot enough to melt lead, and it easily eclipses Mercury. That single temperature reading shatters the campfire rule. Distance alone cannot explain this discrepancy. The mystery here is not the heat source. The anomaly lies entirely in what happens to the energy the moment it actually reaches Venus. This cross-section shows the culprit, an atmosphere of 96% carbon dioxide. On bare rocks like Mercury, incoming heat radiates back into space. But on Venus, solar radiation penetrates the CO2, warms the ground, and ricochets endlessly, blocked by heavy gas. Capping off this atmospheric trap is a final seal, miles of opaque, highly reflective sulfuric acid clouds that lock the system down completely. Venus functions as a closed-loop thermal trap, one that relentlessly converts incoming energy into a permanent layer of surface heat. To test this extreme physics firsthand, the Soviet Union launched the Venera program, dropping heavily armored spherical probes straight into the inferno. As these submarine-like machines descended, they hit a secondary lethal element, generated by the dense gas, an atmospheric pressure 90 times heavier than what we experience at sea level on Earth. The combination of trapped heat and immense atmospheric weight violently overwhelmed the engineering. The titanium hulls were crushed and melted within minutes of touchdown. While the hardware ultimately failed, the brief telemetry transmitted back to Earth served as definitive forensic proof of the runaway greenhouse mechanics. The data confirmed that the surface of Venus is the most hostile terrain in the inner solar system. It is effectively closed off to traditional human exploration. This makes Venus a severe planetary cautionary tale. Billions of years ago, it may have held oceans and mild temperatures, right up until a climate shift pushed it into this irreversible runaway state. Because the ground below is a furnace, sending modern rovers or human astronauts to walk the surface remains scientifically impossible. To ever actually explore Venus, humanity has to abandon our terrestrial obsession with landing and engineer a different method of planetary colonization. This vertical altitude chart reveals the workaround. Looking upward, the lethal surface physics rapidly decay. Exactly 30 miles up, the extremes vanish. Temperature falls to 68 degrees, and pressure drops to 1 Earth atmosphere, conditions similar to a pleasant spring afternoon. A moment of wonder. This altitude is the exact target for NASA's conceptual HAVOC mission. The engineering strategy bypasses the ground entirely, deploying buoyant airship habitats to float permanently within this narrow band of survivable atmosphere. Conquering the hottest planet in the solar system does not require us to survive its surface. We simply have to evolve to sail above it.